friends, today we're going to add on to our concept of exponent rules with, I didn't want to call this video weird exponent rules, but that's kind of where we are. The fractional exponents and negative exponents can be tricky. So here you go with weird exponent rules. All right, so you might see something that looks like a number to the, and I'm going to make it not A. I'm going to change that. Let's say that we have maybe an x squared that we are taking a cube root of. And remember that little 3 on the outside of the root sign tells me it's a cube root. This would be rewritten as x to the 2/3 power. So 2 because the x is being squared, 3 because it is inside a cube root. Now, we know, or we remember, if I have a to the m times a to the n power, this is a to the m plus n power, right? And we know if I've got a to the m raised to the nth power, this is a to the m times n power. So those are our previous exponent rules that we have talked about. Now, when we talk about the fractional exponent, it kind of folds right in with that when we are evaluating them. We say in general, if I have a to the mth power, a to the m power, and we take the n root of that, this would be a to the m over n power. Let's look at an example. So if I had, let's say 4 to the 3rd power, and I'm going to take the square root of that. Well, I could rewrite that as 4 to the 3 over 2 power. Now that looks a little weird, right? I've got a number to a fractional exponent. Many of your calculators will evaluate this for you, provided that 4 has a perfect square root. But we can think about it in a lot of different ways. We can think about it as the square root of 4 times 4 times 4. That makes sense. So that would be thinking of it as 4 cubed raised to the 1/2 power. Here's a trick though. We can also think of it the opposite way. Remember, we've got 3/2 is the product of 3 times 1/2. Another way to think about it is 4 to the 1/2 power cubed. That's the easier way to do it because I know what 4 to the 1/2 power is. That's just the square root of 4. So this would be 2 cubed, which would just be 8. Right? So depending on which one makes it easier to simplify, we can split that 3/2 into 3 times 1/2 or 1/2 times 3. And you'll notice one of them is much easier to evaluate than the other one. Now, I can evaluate this, I just don't really want to because it involves multiplying big numbers, and I'd rather go small numbers first. All right, so fractional exponents give us a way to rewrite things. Now let's look at negative exponents. So the negative exponent rule probably is the weirdest one. A to the negative n power is 1 over a to the nth power. So a negative exponent means a fraction. That can be a little uncomfortable. So for example, if I had 5 to the negative 2 power, this is 1 over 5 squared. And I know what 5 squared is. It's 25. So I could rewrite this as 1 over 25. Now, I like to think of the negative exponent like a ticket. It's like a ticket to get across that division bar. And here's the thing, if you get on a train, you have to give them your ticket. You lose the ticket when you go onto the train. So in the same way, this negative exponent, that negative sign, when you go across that division bar, you lose the negative sign. And it just becomes 5 to the positive 2 power. So let's look at another example. If I had 10 to the, say, negative 3 power, this would be 1 over 10 to the 3rd power. The negative tells us to bring that number to the denominator, but we keep the positive power. All right, well, and then I can evaluate 10 to the 3rd power. That would be 1 over 1,000. Okay. Let's look at one that's a little bit different. What if I had 1/2 and it got raised to the negative 3 power? There's 2 steps here. One is that negative 3 needs to get multiplied, or needs to get applied to everything inside the parentheses. So this would be 1 to the negative 3 divided by 2 to the negative 3 power. Now, really important to notice that 1 to any power is equal to 1. So I could rewrite this as 1 over 2 to the negative 3. Now that negative sign, remember, it's a ticket to go across the fraction bar, either direction. And when we go across the fraction bar, we lose that negative sign. We lose our ticket. So the 2 to the negative 3 can be rewritten in the numerator. So instead of 1 over 2 to the negative 3, I'm going to have 2 to the positive 3 over 1. We don't write the over 1, which is just 8. Now, one other place that we can add negatives, you may have a negative on the front and a negative exponent, and we're going to have to deal with those separately. So for example, if I had negative 4 raised to the negative 2 power. Okay. This negative on the front, that one's separate. It just stays with it while we evaluate 4 to the negative 2. So I'm just going to keep that negative and then write down what 4 to the negative 2 power is. It would be 1 over 4 squared. So I have negative 1 over 4 squared, which would be negative 1 over 16. Now this is not the same as negative 4 in parentheses negative 2 to the negative 2 power. In that situation, I would have, because the negative is inside the parentheses, this would be rewritten as 1 over negative 4 in parentheses squared. And negative 4 squared is just 16. So my final answer would be 1 over 16. So you want to be very careful with the negatives. Know that the negative on the front does not cancel with the negative exponent. And we want to make a careful note of whether the negative is inside the parentheses or outside, because we treat them differently. I'll have another video with some problems like this using all of the exponent rules combined. So definitely check back for that one.